We are wandering through. Oh! That was that's right. Okay, we are jumping into continuing on with 4.4, the second half of it. We're going to do a few more examples and then hopefully set you to task on a little bit of HW homework. So, yesterday we were talking about functions, and then specifically functions and their rules. Functions rule. No, they don't rule. Functions rule.
Cannot be thrown by tyrant.
Function rules.
So, talking of dethrone the tyrant, I said, dude, you cannot dethrone the tyrant.
Okay, in functions we have two things that are going on.
A domain and a range.
Domain and a range. Domain is your inputs, typically what variable? Range is your, typically your which variable? Y. F of x is the same thing as? Y. V of x is the same thing as? Y. Okay. So, this next one, this is a continuation, okay, of 4.4. We'll just, I don't know what number we were on yesterday. How many examples, we finished example 4? So we'll call this example 5. On this one, it's going to say, write, okay, the rule for each function using f of x notation. Write the rule for the function using f of x notation. Now remember, f of x we just said is the same thing as y. So you could write an equation with y equals ... and then at the very end just change y to f of x. Okay, so when we go to look at these, now yesterday we were doing some functions. You know, you had f of x is equal to 1/3 x, which we said y is equal to 1/3 x. If you remember, this is a rule. You input x, you divide by 3, or multiply x by 1/3. That's a rule. So when they are saying write the rule, they're going to give you information. You're essentially just writing an equation for it, something like that. Okay, so you're saying what happens when I input x, and in that case that we were doing that yesterday, you're inputting x, you're dividing by 3. Now we can see that, and then come up with the xy stuff. Here, they're going to give you this information. You're going to have something that looks like this. -4, 2, and then you're going to have -2, 1, and then you're going to have 0, 0, and then you're going to have 2, -1, and then one more on here, 4, -2. I'll give you a second to write all that down, and I'll erase the 1/3. Okay. So we have 5 coordinate points there, right?
Yeah.
Yeah, we do. And so what we have to do is we have to come up with a rule. Like I just erased the rule. Our rule, I'm okay doing like y equals something in terms of x and then change it to f of x at the end is usually probably the easiest thing to do. So what you need to do is you need to write an equation which is like y equals something over here with an x involved. Okay, so an x is going to be involved. So it's going to be y equals and then ... with an x involved over there, right? So it could look like 2x plus 1. It could look like, 3x. We had 1/3 x. It could be -4x minus 7. Those would all be rules. Now, the question is, are any of those ones correct rules for what's going on? The answer is no. But when we're done, it'll look something like this. Okay, y equals something in terms of x. So what we need to think through is, when I plug in x, I get out, when I plug in a -4, I output 2. Now the same rule should apply to, I plug in -2, I output 1. a little tricky with the 0, 0. But when I plug in 2, I output -1/2. When I plug in 4, I output -2. The same rule is applying to every single coordinate point. You're not going to have a different rule for every coordinate point. So when we have, let me do, sorry, it's going back to this, y equals 1/3 x. Remember we said, okay, if I plugged in -6, I outputted -2. If I plugged in -3, I outputted -1, 0, 0. I put in 3, I output 1. I put in 6, I output 2. We had the rule, we could do the mental math to get all those. Now I have these, I'm going backwards trying to write the rule. Does that make a little bit of sense what we're trying to do? Okay, so any thoughts as to if you plug in -4, how does a -4 turn into 2?
Divide by -2.
Okay, you could divide by -2. Let's think about that. If I plug in like a -4 divided by -2, what's -4 divided by -2 give you? 2. Okay. Does that dividing by -2 work for -2, 1? If you take -2 and divide by -2, what do you get back out? 1. If you take 0 divided by -2, what's 0 divided by -2? 0. If you take 2 divided by -2, what do you get back out? -1. And if you take 4 divided by -2, what do you get back out? -2. So dividing by -2 is what you do to every single one. Therefore, to write the rule, you can't just say -4 divided by -2 because we have to have a rule in terms of x.
F of x equals.
Yeah.
Can I tell you?
Yeah.
F of x equals x divided by -2.
Okay. So f of x, so instead of y, because it has to be with f of x notation, we are saying x divided by -2. Now the book maybe has this, either way would be acceptable. They may have -1/2 times x, like that possibly. Either one of these would work for us, okay? So that's what they're looking for you to do, is to logically work through when you input something for x, what do you do to it to get out the y that you want, okay? So let's go with number 6 over here. It'll be the same type of thing, except it's going to be in a chart format like this, where it's a horizontal chart. You have an x and a y. And it'll be like -3, -4, and then -1, -2, and then 0, -1, 1, 0, and the last one they give you is 3, 2. Okay, try to write a rule for that information. Again, the same rule has to apply for each coordinate point, each ordered pair. So the same, when you plug in a -3, you output a -4. The same rule that whatever you did from -3 to -4 has to apply to the next one from -1 to -2. From 0 to -1, from 1 to 0, from 3 to 2. So check with your support team, write the rule of what do you think is going on. It has to have like remember it's going to be an equation, which you can then turn into a function notation, but it's got to have like an x involved, something's happening to it. So you plug in a -3 for x, you output a -4 for y. I don't want the answer right now, I just want everybody to take a chance to try to think through it, and then check with your support team. Check with your support team. Hey, support team. Hey, support team. Okay.
Ethan.
So you do that. How do you get that? How did you get that? Okay,
Okay, Caleb, what'd you put? I saw you raising your hand. You wanted in on this action. Okay, guys, listen. Caleb says y is equal to x minus 1. Let's check it out again, and then in the end, because I said y equals, and then you would change it to this if that's the correct answer. Check it. What you notice is that when you plug in x, you reduce it by 1. You plug in x, you reduce it by 1. Okay? And so, yeah, if you plug in negative 3 minus 1 is negative 4. Negative 1 minus 1 is negative 2. 0 minus 1 is negative 1. And so on and so forth. So you nailed the rule. Usually, if the rule works for at least 2 of them, it should work for all of them. But not, you want to double check that. But usually it'll work like that. Okay, now, you're going to have one like this. Now this gets slightly trickier because I have to draw a graph and make the points known to you. But you're going to be given this, and then like that, and like this, and then like this, and then this. Okay. Now on your homework, it'll be a grid on there. I think yesterday I was struggling to think of like what the term was, but you'd have all the grids on there, and so it'd be really easy to see. This one is maybe a little challenging to see, but not too bad. When you're given this, all you need to do, it's the exact same idea, just in a different format. So over here, they gave you ordered pairs, right? These were all ordered pairs. Here, they were written in a different format, but they were ordered pairs as well. And here, it's just a different format, but did they give you ordered pairs? Yeah, they didn't write the ordered pairs, but can you come up with the ordered pairs? Yeah, absolutely. So when you come up with the ordered pairs, what would this, they don't write it, but we can come up with the ordered pair. What's the ordered pair right here? Negative
2, 4.
Negative 2, 4. Okay, so if you want, you could write the ordered pairs to help you then analyze it the way that you did on the first one and the second one here. And then here, let's double check what is our ordered pair.
Negative 1, 2.
Yep, negative 1, 2. And then that would be 0, 0, right? And then this one's over 1, down 2, and then over 2, down 4. Again, they don't give you those. You could fill them in for yourself. Go ahead and write the rule for this. Check with your support team around you. Say, hey, support team, what did you possibly get? She's not done. Back off.
Got it. Kinley's just like,
The same thing.
you are in. Oh, wait. You are.
Whoa, 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 whoa. Not until you leave on the 20th. Then you can be done.
No, we would have to do class. What'd you get?
What we got.
I can't tell you what answer you
I know.
How do you know? You know how to do answers. You know how to do What'd you get?
What do you get?
That makes sense.
It's the same as last.
I know. It's like x. Wait, is this y equals x?
I'm gonna murder your name here. You know what I mean? No.
Or maybe I don't.
Negative 2. You do know what
And
I
then
mean?
x equals negative.
In a table. And then how do you get negative 2? You multiply it by negative 2. How do you get negative 1 to 2? You multiply it by positive.
I get it.
What?
Yeah.
Dandy.
Dandy.
Is it y equals
negative 2
I was like, so damn.
Damn.
It's like quadruples and
Okay. So let's take a look at this together. Make sure we're tracking. When you plug in -2, how would you go from, so right, the first thing you could say, or one thing you look, if you're just looking at one coordinate point, it's a lot of different options. You could say, well, to go from -2 to 4, you could add 6, right? You plug in -2 and add 6. Or you could multiply -2 by something and then add something else. Or, you can come up with actually an infinite amount of options. But you have to look at what's going from here to here, and then what's going from here to here, and then here to here, because they all have to work together. So if you said, I'm going to add 6 to the -2 to get to 4, that's true, but do you add 6 to -1 to get to 2? No. So that rule wouldn't work. It worked for one of them, but not for the other one. The rule has to work for all of them, and it will work for all of them. So what's another way you can get from -2 to 4? Rosie. Multiply by -2. So when you plug in -2 for x, you multiply by -2, you get to 4. So -2 times x would be our potential rules. When you plug in the -1 and multiply it by -2, you get out 2. When you plug in 0, you get out 0. When you multiply 1 by -2, you get out -2, so on and so forth. There we go. There is our rule. Nice job. -2x. Okay? There is a way down the road that we actually plug these into a formula, and then you can work the formula to get to here. Kind of a guaranteed way to get there. This is just a logical approach that they're asking you to do. There's not a formula that we plug into. Okay? I'm going to do 2 more little examples that will be two more, I think, that deal with writing a rule, a function based off of some following scenarios. So we're going to write a function here with the following scenarios. This is going to be a little bit of writing. I don't love to do this, but I don't have something typed up for you, but you'll be fine. Okay? Or you won't. We'll figure it out. Here we go. If I'm writing, what are you doing? Writing. It's a good skill to learn. If 1 inch of rain, okay, is equivalent, if 1 inch of rain is equivalent to, anybody know how many inches of snow?
10 inches of snow.
10 inches of snow, good word.
Ow.
Actually?
I always heard it was like a foot of snow is 1 inch of rain. I always heard it was like 12 inches of snow is the same as 1 inch of rain, but it's about maybe 10 inches. Yeah.
Oh, so my question for number, like, it's from the previous problem, but it says like in number 20 and 19, it's like, I don't know how to describe it, but on the graph, it's like a full line. How would you?
Same thing, just pick some coordinate points.
Okay.
Yep, figure out the same thing with coordinate points.
So you can just choose whatever. Okay.
There.
And then you can pick random coordinate points.
They're on the line there.
Yeah.
Equivalent to 10 inches of snow. Express the number of inches of snow that is equivalent to R inches of rain. Let me move out of the way here. Of rain. Got sloppy. Okay, so I'm writing, you're writing, I'm done writing, you're still writing. If 1 inch of rain is equivalent to 10 inches of snow, express the number of inches of snow that is equivalent to R inches of rain. So we have 2 things going. What are our 2 things going? Not the numbers, but what are we describing? Snow and rain. What variables might we use when we're dealing with snow? S. I personally don't love S because my S's look like 5s, but we're going to use S. We can make it work. What variable might we use when we're dealing with rain? R. Okay, so we're looking at the variable S and the variable R for snow and rain. Okay, now the challenge can be is that we want to put this in function notation. Now over here, we had something like f of x equals x over negative 2. Okay, f and x didn't describe any specific scenario. It was just a general equation, a rule, mathematical equation we're putting up here. Here, though, we are describing an actual scenario. Inches of snow, inches of rain. So there's two ways we could write this. It's either going to be S of R, or it's going to be R of S, depending on what we do. Okay? So writing a function will have the two variables that we're using, and it'll put it in function notation. So if we write it as S of R, what you're stating is I plug in inches of rain, I output, so if I do this, there you go, it says, if I go S of R equals something, this something over here, whatever it is, what variable will we find on the right-hand side? If I write it as a function S of R, what variable might I find over here on the right-hand side? S or R, which one would I find? You come back over to all the other examples.
R.
If you have f of x, what variable do you find over here? X. F of x. You'll end up with some variable R over there, right? Okay, so when you input inches of rain, you're outputting, what are you outputting then? Inches of snow. So if you inputted 1 inch of rain, how many inches of snow is that? 10. If you inputted 2 inches of rain, 20. Yeah, if you plugged in 3 inches of rain, how much snow do you get back out? 30. So what you are doing, which we just did, you input 1 inch of rain, you get out 10 inches of snow. You input 2, you get out 20. You input 3, you get out 30. You just came up with coordinate points. What's the rule for this? What's our rule going to be for this, Abby?
Oh, S of R equals 10R.
S of R would be equal to 10R.
What?
There you go. Now, how do I know I want S of R instead of, so there we go, done. How do I know I want that instead of, what if I wrote R of S?
And we're solving for X.
Because what they stated, or it's right up here, it says, express the number of inches of snow that is equivalent to R inches of rain. So they want S in terms of rain. If we did it the other way, you could write it. We just know that when you plug in, when you plug in 10 inches of snow, how much rain is that? 1. And you plug in 20 inches of snow, how much rain is that? 2. So that would then be divide. What would you be dividing? You'd be taking your snow divided by 10. Okay? So that would be snow divided by 10. So it'd be 2 different ways to do it, actually. But since they state express the number of inches of snow, that's what they want first. Snow in terms of rain. Okay? If you put that on the test, I might even give it to you. It's like, it's pretty good. Or, tough material, you're on the right track, you're understanding it. Okay. So, but this is the one, put it in red here, this is the one we are aiming for right there. I want to do one more, and then we're done, and we'll have 15 minutes to work here, okay? So one more, and that is number 9 here, our 9th example. It says, write a function, then evaluate the given variable. So the height of a tree in yards. How many feet are in a yard?
3.
3. Good. If you know that it is F feet tall. And then they're going to have something like this, 48 feet. So I'll explain. There's two things going. We've done problems like this in chapter, I can't remember, it said like chapter 2 or whatever, we had write the proportion, then solve. Do you remember that? And I had a little box like proportion, or write the equation, then solve. This would be the same type of thing is that you need to write a function and then you would solve the function for the information. So it'd be like, here's your box function, and then here's your solve, your yards for the tree or something like that. Okay? So you'll have to have two parts. You wouldn't just solve. So what they're stating is the height of the tree in yards if you know that it is F feet tall. Now we want to write a function for this. So you are dealing with the what? Height of a tree, right? If you know that it is F feet tall. So what would we possibly use for our function?
This is evil.
This is evil? Okay, that is one thing to consider. Okay. If you know it is F feet tall, what variable do you think they want us to use? F. Okay. So let's do some basic math. If you knew, or just the one they give us, if you knew the height of the tree is 48 feet, how many yards is that tree?
18.
Not 18, but you're on the right track. Just did a little mental math there. If you know it's 48 feet, how many yards is 48 feet?
20.
No.
23.
It is. Oh wait, I meant.
Let's do this. How do you do the math? How do you do the math, Abe?
48 divided by 3.
Yeah, there you go. As long as we know, like if you're messing up the mental math, that's okay. But yeah, you take your feet divided by how many feet in a yard, right? Feet per yard.
16.
And you have 3 feet per yard, so 48 divided by 3 is 16. So if I said, hey, you have 48 feet, how many yards is it? Hopefully you would say, the yards is 16 yards. That would yield partial credit on the test for the mid-chapter assessment. What they're looking for, though, is also the function. Now, the function should be in terms of F, because it says the height of the tree, you're going to write a function for the height of the tree in yards if you know that it is F feet tall. You took your feet, F, you divide always by what? 3. When you do that, when you take your feet divided by 3, what are you finding? You are finding the yards. So a variable that you might actually write over here, if you're finding the yards, what variable might I use? Y. So the yards, when you are given, it would be y of what?
X.
F.
F.
You're plugging in feet. You're not plugging in x. You're plugging in feet. You are outputting yards. Now, if you said y of x is equal to x over 3, I might give you credit, but formally, you would need to state that x is equal to feet. Otherwise, x is an x, which we don't know what it's assigned to. Y typically is a variable we use, but in this case, y would be understood. What variable would y refer to? Yards, so it would be understood. But x, if you use the variable x, do you see anywhere up here that would be saying x? No. And they specifically tell you to use f. So if you wrote y of x equals x over 3, you would need to state that x is referring to feet. But rather than doing that, why not just write, instead of x, why not just write the variable f? Now, if you did this right here, it doesn't make sense because x and f aren't the same variable. It has to match. I might still give you some credit because you did some of the hard work, but it'd be like, not quite. But why do we say x? Because when we teach functions, what do we always teach initially? F of x, f of x, f of x. Right, so we did. You want me to do it one more time?
No.
Yeah.
You guys. F of x. Alright, who wants a cry baby? Who feels like crying?
Do you love the chocolate left?
I have a purple. You want it? Duck. Did you catch that? No way. Actually, that's really mean. Like, I can't believe you caught that. Of course you caught it. We know your
like,
skill.
I thought.
I got an orange crybaby. Orange. I got a yellow crybaby. Yellow.
Yes, that's the best one.
I got a green crybaby.
Yellow is real.
Sorry. I got a yellow crybaby.
Yes, that's yours.
I got a blue crybaby.
That's me! Yay!
I got a yellow crybaby. Only one per person. I got a yellow crybaby. I have an orange crybaby. I have a green crybaby. I have a yellow crybaby. And I've got a purple Laffy Taffy. And one per person. I feel like there's trade. Purple Laffy Taffy. Ready for the trade? You gotta do this. Yep. Nice. That was a sweet treat. A yellow Laffy Taffy or a purple. I'm sorry. A yellow crybaby or a purple Laffy Taffy.
Yellow. I'll switch.
Okay, yellow. What do you have in exchange? You have nothing. You have something.
Thank you.
Okay, I have one purple Laffy Taffy. Has anybody not received something up to this point?
I want it.
Everybody's received something up to this point.
I received.
We'll gamble for the purple one.
We will gamble for the purple Laffy Taffy. Okay.